a telephone exchange in rural Somerset, installed in 1952, still working in 1985. Mechanical relays clicking through connections, routing calls through copper wire networks, built by the Plessey Company Limited. The engineers who installed it had calculated it would last 25 years. It lasted 63. In the 1980s, Margaret Thatcher's government encountered a problem. Plessey made the equipment that allowed Britain's military to function: radar systems, encrypted communications, missile guidance. The company held 847 patents related to national defense, yet the government decided it must be destroyed. Not restructured, not privatized, destroyed completely. By 1991, Plessey no longer existed. The technology was scattered across German and French conglomerates. The factories were demolished. Thousands of engineers found themselves unemployed, their expertise suddenly worthless. Nobody has adequately explained why this had to happen. Alan Clark failed his mathematics examination in 1927. The irony would become apparent later. The son of a Staffordshire tile manufacturer, Clark had been expected to join the family business. Instead, he became obsessed with wireless telegraphy. At 19, he was experimenting with vacuum tubes in his father's workshop. Burning through money meant for production equipment. His father cut him off. Clark borrowed £200 from his maternal uncle and registered a company called Plessey in 1917, named after the village of Plessey in Northumberland, chosen seemingly at random from an atlas. The company initially manufactured components for wireless sets, small contracts, regional customers, nothing remarkable. Then in 1923, Clark won a contract to supply components to the General Post Office for their new automatic telephone exchanges. The contract was worth £4,500, more money than Clark had seen in his entire life. He hired 12 workers and rented a larger workshop in Ilford, Essex. By 1930, Plessey employed 238 people. Clark had developed a manufacturing process for precision wound coils that reduced interference in telephone lines. The post office became dependent on these coils, so dependent that when Clark raised his prices by 15% in 1931, they paid without negotiation. The civil service recognized monopoly power when they saw it, but the technology worked better than anything else available. Clark understood something fundamental about government contracts. Once your equipment is installed in a critical system, you own that customer forever. Replacement costs exceed maintenance costs. Training costs exceed retraining costs. Incompatibility creates lock-in. By 1935, Plessey components were embedded in every major telephone exchange in southern England. The company had become infrastructure. The Second World War transformed Plessey from a components manufacturer into a defense contractor. The Ministry of Supply needed radar systems. Plessey had engineers who understood electromagnetic frequency. Clark converted 3 factories to classified work. By 1943, Plessey employed 3,100 people, working on projects they were forbidden to discuss, even with their families. The company manufactured radar sets, encrypted radio systems, and proximity fuses for anti-aircraft shells. After the war, this classified work never stopped. It simply changed classification levels. The Plessey headquarters at Vicarage Lane, Ilford, Essex. 7 buildings connected by underground tunnels. Security checkpoints at every entrance. Entire floors where visitors were forbidden. Employees carried color-coded badges, white for public areas, blue for sensitive areas, red for classified work. If you held a red badge, you couldn't leave the country without ministry approval. Some engineers worked at Plessey for 30 years without knowing what their colleagues 3 doors down were building. The tunnels connected manufacturing areas to research laboratories. Components moved underground, invisible to observers. During the Cold War, MI5 conducted regular security sweeps. They found listening devices 3 times, Soviet devices twice, American devices once. Nobody discussed this publicly. The Official Secrets Act applied to discussions of security breaches as much as to the classified work itself. Michael Clark, Alan Clark's son, took control in 1952. Where his father had been cautious, Michael was expansionist. Between 1955 and 1970, Plessey acquired 37 companies, defense contractors, telecommunications firms, electronics manufacturers. Some acquisitions made strategic sense, others seemed motivated by Michael Clark's belief that bigger always meant safer. By 1970, Plessey was the third largest defense contractor in Britain, behind only British Aerospace and Ferranti. Annual revenue exceeded £280 million. The company's product range became absurd in its diversity. Plessey manufactured radar for RAF fighters, traffic lights for Birmingham, telephone exchanges for the post office, semiconductors for Ferranti, hearing aids sold through Boots, avionics for Concorde, office intercom systems, military encryption devices, portable radios sold under the brand name Plessey Personal. Nobody could explain the coherent strategy behind this sprawl. When analysts asked Michael Clark, he would say, "We make things that communicate." This explained nothing. But beneath the chaos, 3 product lines generated 73% of revenue: military radar systems, telephone exchange equipment, and semiconductors. Everything else was noise. The Ministry of Defense alone accounted for 41% of sales. This created vulnerability. Plessey's survival depended on government spending priorities. When defense budgets grew, Plessey thrived. When budgets contracted, the company struggled. And in 1979, Margaret Thatcher's government began restructuring defense procurement. Here is what made Plessey different from other British manufacturers. Most companies could be sold to foreign buyers without compromising national security. You could sell Jaguar to Ford without revealing military secrets. You could sell Rowntree to Nestlé without threatening defense capability. But Plessey held contracts for systems so sensitive that even acknowledging their existence violated the Official Secrets Act. The Ptarmigan Tactical Communication System, developed by Plessey starting in 1976, mobile battlefield communications that couldn't be jammed or intercepted. The system used frequency-hopping spread spectrum technology, constantly switching between transmission frequencies to prevent enemy detection. Every British Army unit deployed overseas relied on Ptarmigan. The system was so classified that Plessey engineers working on different components weren't allowed to discuss their work with each other. The Type 996 naval radar, installed on Royal Navy destroyers and frigates, three-dimensional surveillance radar, capable of tracking 400 targets simultaneously. Plessey developed this system between 1972 and 1981 at a facility in Roke Manor, Hampshire. The research required 6,000 engineering hours and cost £34 million in development funding from the Ministry of Defense. By 1985, every major British warship carried Plessey radar. The Skyguard fire control system, manufactured under license from the Swiss company Oerlikon. Plessey modified the original design, adding their own radar and computing systems. The modified version could track and engage low-flying aircraft that other systems missed. The RAF used Skyguard to protect airfields. The modifications Plessey developed were classified. Selling the company meant transferring these modifications to whoever bought it. Between 1960 and 1985, Plessey had signed 412 contracts with the Ministry of Defense. Many involved multi-year development projects. Some wouldn't be completed until the mid-1990s. The company employed 2,400 engineers who held security clearances. Their knowledge of British defense systems couldn't simply be erased. Selling Plessey meant selling access to decades of classified research. This created the paradox. The British government wanted to reduce defense spending and consolidate the defense industry. But Plessey couldn't be merged with British Aerospace. The two companies competed for the same contracts. Plessey couldn't be sold to an American company. The Americans already dominated defense technology, and the optics of dependency were politically unacceptable. The company couldn't be privatized through public offering. The classified work couldn't be disclosed to investors. The only option remaining was to sell to European competitors, which meant handing Britain's defense technology to France and Germany. The General Electric company, known as GEC, was led by Arnold Weinstock, a man described by colleagues as commercially brilliant and personally unpleasant. Between 1963 and 1983, Weinstock had transformed GEC from a struggling manufacturer into Britain's largest electronics conglomerate. He achieved this through aggressive acquisitions and ruthless cost-cutting. Weinstock's management style was notorious. He would arrive at factories unannounced, fire managers on the spot, and shut down entire divisions if quarterly returns disappointed him. In 1985, Weinstock decided GEC should acquire Plessey. The rationale seemed sound. Both companies worked on defense contracts. Both manufactured telecommunications equipment. A merger would eliminate duplication and create a British electronics giant capable of competing with Siemens and Thomson CSF. Weinstock offered £1.2 billion, a premium of 34% over Plessey's share price. Plessey's board rejected the offer. Not because the price was inadequate, they rejected it because they didn't trust Weinstock. The chairman, James Leng, had watched Weinstock acquire and dismantle 3 companies Leng had worked for earlier in his career. Leng knew what would happen. Weinstock would close Plessey's research laboratories, fire half the workforce, sell the profitable divisions, and shut down everything else. The Plessey name would disappear. The company would be cannibalized. Weinstock launched a hostile takeover. He bought Plessey shares on the open market. He lobbied government ministers. He gave interviews to the Financial Times explaining why the merger was inevitable and necessary. Margaret Thatcher's government supported the takeover. They saw it as an efficient consolidation that would strengthen British defense capability. The Secretary of State for Trade and Industry, Leon Britton, publicly endorsed Weinstock's bid. Plessey fought back. They sued GEC, claiming the takeover violated antitrust regulations. They lobbied the Ministry of Defense, arguing that a merger would compromise classified projects. They convinced institutional investors that Weinstock would destroy value rather than create it. The battle lasted 2 years. Legal costs exceeded £47 million. Both companies spent more time fighting each other than running their businesses. In 1987, the Monopolies and Mergers Commission blocked the takeover. The decision stunned Weinstock. The commission ruled that combining GEC and Plessey would create an unacceptable monopoly in defense electronics. Competition was necessary for innovation. A single dominant contractor would lead to complacency and inflated prices. Plessey celebrated. They had survived. But survival created a different problem. Plessey had spent 2 years and tens of millions of pounds fighting GEC. Research budgets had been cut to fund legal battles. Projects had been delayed. Customers had grown nervous about the company's stability, and Weinstock, humiliated by the rejection, began planning revenge. If he couldn't acquire Plessey alone, he would find a partner. In 1988, Arnold Weinstock approached Siemens AG, the German electronics conglomerate. He proposed a joint takeover. GEC and Siemens would acquire Plessey together, then divide the assets. GEC would take the defense divisions. Siemens would take the telecommunications and semiconductor businesses. The cost would be shared. The regulatory concerns would be eliminated. A joint acquisition by British and German companies couldn't be blocked on monopoly grounds. Siemens agreed. In February 1989, GEC and Siemens offered £2.0 billion for Plessey. The offer was structured carefully to avoid regulatory rejection. GEC would acquire 60% of the company. Siemens would acquire 40%. Then immediately after completion, they would swap divisions. The structure was legal, but transparently designed to circumvent the Monopolies Commission's earlier ruling. Plessey's board recognized they had lost. 2 companies controlled by determined executives with unlimited resources could not be defeated. Fighting would be expensive and ultimately futile. In July 1989, Plessey accepted the offer. The company was sold for £2.1 billion after a brief bidding war. Alan Clark's company, built over 72 years, would be dismantled and distributed to foreign competitors. The Ministry of Defense approved the sale. Their reasoning was never fully explained. Internal memos, partially declassified in 2009, suggest the ministry believed GEC would manage the defense work competently. The telecommunications assets going to Siemens were considered less strategically sensitive. Some documents hint at pressure from the Prime Minister's office to approve the deal quickly. Margaret Thatcher wanted the sale completed before the 1990 elections. A successful consolidation would demonstrate her commitment to efficient markets. Between August 1989 and April 1991, Plessey was systematically dismembered. GEC took the defense divisions, radar, avionics, communication systems, naval equipment. Siemens took the telecommunications and semiconductor operations. The Ilford headquarters was sold to a property developer. The 7 buildings were demolished in 1992. Housing estate now. 273 families live where engineers once developed classified radar systems. No plaque marks the location. 14,000 employees were made redundant. Some found work at GEC, some retired. Many simply left the industry. Their skills were too specialized. Who needs engineers trained in 1960s radar technology when the defense industry is consolidating? The government offered retraining programs, courses in business management and information technology. Engineers who had spent 30 years developing weapon systems were taught to use Microsoft Excel. Siemens AG acquired Plessey's telecommunications and semiconductor divisions in 1989. The assets included factories in Swindon, Liverpool, and Towcester, research laboratories in Caswell and Poole, patents covering digital switching systems and gallium arsenide semiconductors, customer contracts with British Telecom, cable and wireless, and dozens of international telecoms providers. Siemens paid £840 million for these assets. On paper, the acquisition looked reasonable. The telecommunications division generated £320 million in annual revenue. The semiconductor operation was profitable. What happened next remains controversial. Between 1990 and 1995, Siemens shut down every major research laboratory they had acquired from Plessey. The Caswell facility, where Plessey had developed gallium arsenide semiconductors, closed in 1991. Equipment was shipped to Munich. The Poole Telecommunications Laboratory closed in 1993. Research transferred to Siemens facilities in Germany. The Swindon factory, which manufactured digital telephone exchanges, closed in 1994. Production moved to France. British telecom executives watched this happen with growing alarm. They had relied on Plessey for 20 years. The equipment was proven. The engineers understood British telecommunications infrastructure. Now their supplier was German, and research was happening in Munich. When problems occurred, resolution took weeks instead of days. The personal relationships that had facilitated quick solutions were gone. Some observers suspected Siemens had never intended to maintain Plessey's operations. The acquisition was about eliminating a competitor. Plessey had been developing digital switching technology that threatened Siemens' market position in Europe. By acquiring and closing Plessey's research labs, Siemens removed that threat. The £840 million purchase price was simply the cost of eliminating competition. Whether this interpretation is accurate remains debated. Siemens declined to comment on their strategic rationale when questioned by journalists in 1995. The semiconductor division suffered similarly. Plessey had been developing gallium arsenide chips for high-frequency applications, military radar, satellite communications, mobile phone infrastructure. The technology was ahead of silicon-based alternatives for these applications. Siemens acquired this research, then apparently did nothing with it. Patents were allowed to lapse. Engineers were laid off. By 1998, Siemens had sold the entire semiconductor operation to Matra Marconi Space for £180 million, a 79% loss on their original investment. Where did the expertise go? Some engineers moved to Siemens facilities in Germany. Most did not. Language barriers, family commitments, reluctance to emigrate. They found work elsewhere or left the industry. Britain lost decades of accumulated knowledge in telecommunications and semiconductor technology. The knowledge didn't transfer to other British companies. It simply vanished. The General Electric Company acquired Plessey's defense divisions in 1989. The assets included naval radar systems, military communications equipment, avionics, and electronic warfare systems. Arnold Weinstock had won. He controlled Britain's largest defense electronics business. The question was what he would do with it. Weinstock did what everyone expected. He cut costs. Between 1990 and 1996, GEC closed 6 Plessey research laboratories. The Roke Manor facility in Hampshire, where Plessey had developed naval radar, was sold to Siemens in 1991 for £62 million. The facility had cost £180 million to build. GEC took the loss and moved on. Research budgets were cut by 40%. Projects that wouldn't generate revenue within 3 years were canceled. Thousands of engineers were made redundant, not immediately. Weinstock was too clever for mass layoffs. He used attrition. When engineers retired or left, they weren't replaced. Departments shrank gradually. By 1995, GEC employed 6,800 fewer people in defense electronics than when they acquired Plessey. The cost savings were substantial, GEC's profit margins improved from 8.4% in 1989 to 13.2% in 1995. But something else happened. Innovation stopped. The engineers who remained were focused on cost reduction, not development. New products took longer to reach market. Quality problems increased. The Bowman Tactical Communication System, intended to replace Plessey's ptarmigan, was delayed repeatedly. The first units weren't delivered until 2004, 7 years behind schedule. The Ministry of Defense blamed poor project management. Industry observers blamed Weinstock's cost-cutting. In 1996, Arnold Weinstock retired. George Simpson replaced him as managing director of GEC. Simpson had different priorities. He wanted to transform GEC into a global technology company. Defense contracts were boring, stable revenue but limited growth. Simpson decided to sell GEC's defense operations and invest in telecommunications and internet ventures. In 1999, GEC's defense businesses were sold to British Aerospace for £7.7 billion. The assets included everything GEC had acquired from Plessey 10 years earlier. British Aerospace, renamed BAE Systems, became Britain's sole major defense contractor. The consolidation Weinstock had sought in 1985 was finally complete. But the company that emerged bore little resemblance to Plessey. The research culture was gone. The engineering expertise had dispersed. What remained was a portfolio of products and contracts managed by accountants rather than engineers. The Bowman Tactical Communication System was supposed to replace Plessey's ptarmigan, modern digital communications for the British Army, secure, reliable, interoperable with NATO allies. The initial specification was written by Plessey engineers in 1988. Development was projected to take 6 years and cost £340 million. The system would enter service in 1995. It didn't. After GEC acquired Plessey, the Bowman project was delayed, restructured, and delayed again. Engineers who understood the original specification left or were laid off. Requirements changed. The Ministry of Defense demanded new features. Costs escalated. By 2000, projected costs had reached £2.4 billion. The project was transferred to a consortium led by General Dynamics, an American defense contractor. Bowman finally entered service in 2004, 9 years late, and 7 times over budget. The equipment worked, but it was obsolete before deployment. The technology was based on specifications from 1988. Mobile phone networks were more advanced than military communications. Soldiers complained the radios were heavy, unreliable, and incompatible with vehicles. The system that was supposed to revolutionize battlefield communications became a symbol of procurement failure. Could Plessey have done better? Impossible to know. But people who worked on ptarmigan say yes. Ptarmigan was delivered on time and on budget because Plessey controlled the entire development process. They manufactured components, they wrote software, they tested systems, they trained users. Vertical integration meant accountability. When GEC dismantled Plessey, that integration was destroyed. Bowman was developed by committees coordinating subcontractors across multiple countries. Nobody owned the complete system. The comparison is striking. Ptarmigan cost £340 million and worked flawlessly for 25 years. Bowman cost £2.4 billion and was plagued by problems. The difference wasn't technology. It was institutional knowledge and organizational structure. Plessey understood military communications because they had been building military communication systems since 1940. GEC understood cost reduction. When forced to choose between those competencies, cost reduction won. In 2010, the British government published a review of defense industrial capability. The report noted that Britain had lost the ability to independently develop critical defense technologies, radar systems, secure communications, electronic warfare equipment, semiconductor manufacturing. The expertise existed within BAE Systems, but it relied on components and subsystems from foreign suppliers. True independence was gone. The report didn't mention Plessey by name, but people who worked in defense electronics understood the subtext. In 1985, Britain had 4 major defense contractors capable of independent development: British Aerospace, GEC, Ferranti, and Plessey. By 2010, only BAE Systems remained, and even they depended on American and European partners for critical technologies. What was gained by destroying Plessey? Cost savings in the short term. Between 1989 and 1995, the consolidation of defense electronics probably saved the Ministry of Defense £200 million annually. But Britain lost strategic capability. When the Falklands War occurred in 1982, British forces used radar and communication systems designed and manufactured in Britain by companies that understood British military requirements. When conflicts occurred after 2000, British forces increasingly depended on American technology. The irony is that other countries protected their defense industrial base. France merged Thomson CSF with other defense contractors to create Thales, but kept the capability in France. Germany maintained Rheinmetall despite international competition. The United States never seriously considered allowing critical defense contractors to be acquired by foreign companies. Britain alone decided that market efficiency mattered more than strategic autonomy. Alan Clark died in 1962, long before any of this happened. He never saw GEC acquire his company. He never saw Siemens dismantle the telecommunications division. He never saw the Ilford headquarters demolished. His obituary in the Times described him as a pioneer of British electronics. 74 words. No mention of what he built. No mention of what it became. The Plessey name survives as a brand owned by various companies. Plessey Semiconductors, a small firm in Plymouth, manufactures microelectronics for aerospace applications. They license the Plessey name but have no connection to the original company. A different firm called Plessey Marine manufactures navigation equipment. Also, no connection. The name persists because it sounds technical and British. The substance is gone. In 2023, the British government announced plans to develop a sovereign capability in semiconductor manufacturing. The rationale: dependence on foreign suppliers creates strategic vulnerability. The program will cost £2 billion over 10 years. In 1989, Britain had sovereign capability in semiconductor manufacturing. It was called Plessey. Siemens bought it for £840 million and shut it down. Now, 34 years later, the government will spend £2 billion to recreate what it allowed to be destroyed. Nobody has been held accountable. The ministers who approved the sale are retired or dead. Arnold Weinstock died in 2002. The Siemens executives who closed the research laboratories have moved on. The decisions that dismantled Britain's defense industrial capability are treated as historical inevitabilities, unfortunate but unavoidable consequences of market forces, as if markets are forces of nature rather than systems designed by people making choices. 3 simple conclusions. Britain had a defense electronics capability that worked. The government decided it should be sold to foreign competitors. The capability was lost and has not been recovered. Everything else is commentary.